In the last video, we spoke about the startup Kickstarter, and we also discussed one of the big issues that they have today. In an ideal world, anyone starting up a project on Kickstarter will collect some amount of money from some contributors. All that money gets sent to the project manager, or essentially the idea person, the person who is going to make this thing happen. In an ideal world, that project manager would then take that money and maybe send it off to some vendors, right? They are not going to build, say, plastic casings themselves, so maybe this idea person is going to work with some outside vendors to get these basic parts put together, and then the idea person will then assemble those parts into the finished product. So this is just a for example. Let's just imagine that every Kickstarter campaign works with some number of external vendors. At the end of the day, they are collecting money for something, right? They got to be spending the money on something. So it's not unreasonable to say that all this collected money eventually gets sent out to some outside party by this idea person. Again, this is the ideal world. This is really what we want to have happen to see a successful Kickstarter campaign. However, the reality is a little bit different. So here is sometimes reality. Of course, there are very many successful Kickstarter campaigns, but sometimes this is what happens. We get all these contributors, they send money to the idea person, and then unfortunately, that money ends up in some private bank account, which is instead going to supply a vacation and a brand new BMW. So obviously not ideal. We don't want this to happen. So what's the common denominator between these two situations? Or maybe a better thing to say is, what's the difference between the two of them? Well, it appears that the big difference between these two situations is where this money goes. If we could somehow control this money being sent not to a private bank account, but instead to some vendor who's going to supply real project supplies that can be used to build some product, then it seems to me like we might have a little bit more successful product or campaign on our hands. That's going to be the exact goal of the contract that you and I are going to design. We are going to build a contract that is going to try to control where this idea person can send money to. So let's walk through this contract and discuss exactly how it's going to be put together. All right, so we're going to walk through a couple diagrams. We're going to start off with this very basic diagram. So at a very low level, we're going to say that contributors to a campaign are no longer going to be sending money directly to some manager or idea person. Instead, these contributors are going to send money to an Ethereum contract. So this contract is going to have some amount of code that regulates who can receive money from the campaign. We can think of this contract right here as representing the actual campaign. It's like a public display of all the expenses and fundings of the campaign. So how do we actually get money out of this thing then? How does the manager somehow work with the contract and say, okay, I need to actually make use of the money that's inside the contract now and use it to pay a vendor, as is what we really want to do over here, right? We want to pay vendors because that's probably going to lead us to a successful campaign. So in order for a manager to actually spend money, we're going to say that they have to create something called a spending request. So in the contract, they're going to call a function that creates a spending request. A spending request is going to attempt to withdraw money from the contract and send it to some specific external address. And in this case, we're going to say that this external address is some vendor. So maybe it's someone who's going to make a battery casing for us, or an LCD display, or some sensor clips. Essentially, someone who is going to help us further the campaign along and make sure that we actually are trying to build a product and not just run away with all of our money. So how does a spending request actually do anything though? Well, here's the twist. Here's the fun part. So here's where the real Ethereum stuff starts to come into play. We're going to say that the manager has the responsibility to create a spending request to pay an outside vendor, right? That makes sense. But here is the interesting part. We're going to say that all of the people who contributed to a campaign have to vote on every spending request. So manager says, hey, I need like $100,000 to buy some battery casings. They're going to create a spending request inside the contract. It will then be up to all of the contributors to call a function on the contract to approve that spending request. So each of these contributors right here have to call a function to approve the spending request. If enough people approve the request, then the funds automatically get sent to this outside vendor, and in theory, that vendor will now deliver some supplies to complete the campaign. However, if too many people vote no, then that is an indication that this is a bad request and that the manager is mismanaging the campaign in some fashion, and they really need to get their act together. Otherwise, these contributors are not going to approve the spending request, and no money will be able to be spent out of the campaign. So obviously this might have a couple of holes in it. For example, we're kind of relying on the fact that all these contributors are either going to vote yes or no. We're also making the assumption that the manager is not going to try to trick these contributors into sending this money to a fraudulent address or a fraudulent vendor. Yeah, there are issues like that. However, at the end of the day, this approach right here goes a lot farther to producing successful campaigns in the real world than the current Kickstarter system. The current Kickstarter system says, okay, manager, here's your money, go and do the right thing. And there's no outside control whatsoever from these contributors. They send their money into Kickstarter and that's pretty much it. They wave goodbye and they can do not a single darn thing to influence the campaign whatsoever or make sure that it's being ran responsibly. So with this type of approach, by using an Ethereum contract, at least these contributors have an idea of where their money is being sent to, and they have the ability to review these spending requests before the money gets spent. So again, maybe it's not the perfect solution in the world, but it at least gives a lot more power to these contributors than they would otherwise have. All right, so that's pretty much it. That is our solution. That's how we might use an Ethereum contract to solve this problem that Kickstarter has. Now you might be thinking, okay, Stephen, that's great. Sounds like a solution, whatever. Well, hey, it's not enough to just talk about this. We're gonna build this, right? So in case it's not clear, we are gonna build this contract. You and me, we're gonna build this thing. It's gonna have all the functionality that I just discussed, and then we're gonna put together a fantastic looking front end application to sit in front of all this. And at the end of the day, we are gonna have a system that very closely approximates how Kickstarter behaves. So this is going to be just an exceptionally exciting project. I can't tell you how excited I am to get started on it. So let's pause right now. We're going to come back in the next video and we're going to start writing some code to build this Kickstarter clone. So I'll see you in a minute.